you see that the objects that we have right here, ID1, ID2, and ID5, when we go to the next frame, now there is a connection between them. Welcome to this new video. I'm Sergio, and in this video, we're going to see how to detect and track any object using Python and OpenCV. So we're going to see how to do this implementation in a very easy way from scratch, step by step. You will understand the difference between detection versus tracking and why this is crucial to get the most reliable and the best accuracy tracking of your objects. And then we're going to also see how to get the best accuracy by checking the best practices and also avoiding the most common mistakes, also comparing and testing different algorithms. We will test everything on different type of videos. For example, for vehicle tracking, we have here from CCTV camera vehicle tracking. Here we will test on these videos different algorithms and their implementation for people detection and tracking. These other samples, this one, and a few others, so that you can understand where the algorithms work the best and which one to use and how to use it. Despite we have so many object tracking algorithms, so if you search on papers with code, you see each year coming a lot of algorithms. So this is a list of object tracking algorithms, but not always their implementation is simple when you need to go into practice and write the code. So today we're going to see how to make the implementation very simple, and also you will understand the logic on how the object detection plus object tracking should work. Let's now start writing the code to detect the vehicles on this image, and then we do object detection and I will implement object tracking. Let's go. Now I'm going to write the code very fast, but at the same time I will give you enough explanation of each line so that you can understand what we're doing. If you want all the sources that I'm using right here and all this simple implementation, everything is available inside the AI Vision Academy, and the link is below in the description. Later I will tell you more about the Academy. For now, let's go to the lesson. So first of all, we want to detect the vehicles in the video that I show you. So detect the vehicles means draw a bounding box on each vehicle. How do we do that? First, we need to load the video. So we import CV2, which is the OpenCV library. We need to, you see the Copilot is suggesting something already. We load the video. We need to create a capture object, CV2.video capture, and then here we put the path of the video. I have a folder demo where I have the video, which is called vehicles. I have a few videos. I showed you now the specific one I want to load is vehicles 4.mp4. Now, what do? We need to load extract the images from the video one by one. So we go on a loop. So while true, and here we want ret frame cap read. Here we get the frame. Ret is saying if there is or not frame, because the video is not infinite. So when there is no frame anymore, we want to stop the video. Now let's display the frame. CV2.im show the title of the window and then frame await key event. Key equals CV2 dot wait key, so that if we press any key we can close the video. And also, so if the key is 27, which is the key on the keyboard, we quit. And that's pretty much what we want to do. So cap.release to release the video, and then CV2.destroy windows to close everything. If everything is correct, if I run this one now, we should see the video. It runs, and of course it's short, so it quits, but it doesn't matter now. We'll test also longer videos later. We have now the video. What do we want to do with this video? We want to perform object detection. So let's proceed with that. From engine.object detection, we're going to import object detection. Now we create here, we load the object detector, load object detection model, OD equals object detection, and here we specify which model we want to load. So models, now we're going to use YOLO version 11. You can use any model, you can use 12. Depending on when you're watching this video, there might be a much newer version because they evolve so fast. Every few months there is a new model, so it's very hard to keep up with them. It doesn't matter because the structure of them is the same. So you get a better, faster, with more accuracy model, but the way we load them, it's the same. So don't worry if there is a newer model when you're watching this video. And then when do we find and detect the objects in the video? Here we get the frame right here. After we get the frame, on that frame, we want to detect the objects. So right here, detect objects in the frame. And how do we do this? We do od.detect frame. Very simple. So we use the object detection we created and we say, okay, we use the object detection model, detect where we want to detect on the frame. What do we get from the object detection model, we get three things in return. We get the bounding boxes, we get the class IDs, and we get the scores. So if we print very quickly bounding boxes, okay, you see now printing in real time the location of each bounding box about the detection in this video. And of course, we're just printing them so we don't see anything on the screen because we're not drawing anything. But here on each frame, you see we have an array and then we have other arrays. So this for each frame, we have different bounding boxes. We have the location of each vehicle. So we're going to use them and show them. So we draw using these coordinates everything on the screen. So now let's loop through everything for bounding box, class ID, core, in, and we loop through everything that we have, the bounding boxes, class IDs, and scores. For the bounding box, we get the X and Y location, top left point, right bottom point. So let's draw for that a rectangle. And that's what we got. We get now the object detection of the vehicles right here. Why are we able to detect this? Because our model that we're using, YOLO version 11 at this moment, but in general, the pre-trained models that you can find accessible online, they are trained on Coco dataset, which can detect 80 different categories. To give you some context, here I am now on the Coco dataset website, and if we go on Explore, here we have the different objects that we can detect, person, backpack, and so on. There are 80 different common objects. That's why it's called Coco, common objects in context, 80 of them. And so among them, we can detect the vehicles, and we're doing that right now. Let's now add some more information to the detection, because we have the bounding box and we are drawing them, but we have also the class ID and the score. The class ID is telling us which object we are identifying, so what type of vehicles and so on. So we can display class name, and right here from the Copilot, we have the class name. That's what we get. We get object detection. Now let's break down what object detection is. The easiest way to understand is to pause between each frame. In the key event, I'm going to put 0, which will pause instead of waiting for the next frame. That's the first frame of the video, and we're doing object detection on this frame. Let's now focus, for example, on these three different cars that we have right here. And when we do this, when we use the vehicle management system and object tracking, the idea of such software is to count and classify the vehicles. So what we want is, if we draw a line like this, for example, we want to say, okay, when the car or the vehicle crosses that line, we want to make the count. Same is for any type of tracking, whether it's with people or with different objects in manufacturing, doesn't matter. That's the concept. You have a point when you cross that point, you do the counting. So this is a way of using object tracking. When we have object detection like we have now, that's not possible to do. We cannot do that because object detection is detection on a frame after a frame, because a video is nothing more than a frame after frame. Even if we see things moving, so that's the first frame, now we have a second frame, now we have a third frame, and so on. On this, we don't know that this car right here that now I'm marking red, it's clear for us that it's the same, that now it's moving. So you see, but for the computer, the car that was right here before and that's not here, it's not clear. There is no connection between the previous frame with this frame, because what we have is only arrays with the position of the location of each bounding box, and that's all our software at the moment knows. And that's why it's so important to have object tracking, and why it's so crucial to have object tracking in most of the computer vision application, to be able to get some data and to make analysis on what we see in the video. For this reason, object detection is of course the first part of object tracking, because in order to see the connection between them, we need of course to first detect them. So object detection is essential, but after object detection, we need to go and do object tracking. Let's now implement object tracking, and later we will understand more about it and some difference between the algorithms and so on. In order to implement object tracking, now we need to import also the library from engine.object tracking. We're going to import multi-object tracking, and then right here at the beginning of the code, load the object tracker model. So MOT equals multi-object track. And now we define the tracker. In this implementation, I have three different tracking algorithms. Let's start with the most basic one that we have. It's StrongSORT. And how does this work? The concept is very simple. Now I'm going to put a comment on all the code that we use to display the bounding boxes and object detection. I could actually even remove this. And then what is the object tracker going to do? The object tracking is an algorithm that takes the bounding boxes, the class IDs, the scores, and also some of them take the frame, combines them, and then we get update information with a univocal ID then it will be more easy when we see that into practice. So let's do that. Tracker.update, we give frame, bounding boxes, class IDs, scores. We're going to get bounding boxes with IDs equals tracker.update and so on. And let's now loop through everything. So for b bounding box ID in bounding boxes IDs, it's very similar to what we get from object detection. So we get x1, y1, which is the top left point of the rectangle, x2, y2, which is the right bottom point of the rectangle. Then we're going to get object ID, class ID, core equals np.array bounding box ID. So here we're using NumPy to extract. NumPy is a library to make the array operations very efficient, and that's essential when we work with computer vision because we need fast processing on each frame. Now let's draw this and let's make sure that everything is working. So for the moment I'm going to just draw the rectangle, and later we'll get more into what is each information that we see right here. So the code that we have now is working. As you see right here, again we have bounding boxes as we had before, but there is an addition to this one, and it's the most important part of object tracking, which is the object ID. What is this? This is a univocal ID that is associated to each single object that we see. So let's now display object ID before displaying everything else. Let's make some quick fixing here. So I want to display ID, and then right here we put object ID. Now you see each one of them has an ID. So we have ID1, ID5, ID2 for the vehicles that we were watching before. Let's now go to the next frame. You see that the objects that we have right here, ID1, ID2, and ID5, when we go to the next frame, now there is a connection between them because the tracking algorithm is giving them a univocal ID and it's keeping them on the way. So if we want to count the vehicles, we can simply draw a line. So right here we draw a line, and then we can check if ID5, ID2 or whatever, they cross that line, and we can have a very accurate counting by doing this simple approach. Now we'll not focus on object counting, that could be for another video. You can let me know if you want to know more about object counting. Let's now put the video again, but let's now remove the pause between each frame so that we can see this happening in real time. And now you see they are moving, and we see that the IDs are following that. This is now a first step approach in object tracking. Let's try different videos, and later we will also see how to improve, because now this is just an introduction about the object tracking. But if you try object tracking first, congratulations if you were able to already do this with the sources, but then you might have encountered some error and some problem with keeping the ID between the frames. Let's try some more challenging videos. Let's get another city traffic about vehicles. So this is a bit more complex because we have smaller objects, so the view is much bigger from the camera. So you see the vehicles are in general much smaller, and it's hard to keep the ID between them. Maybe it's not clear now, the video is moving a bit fast, but some of them are losing the IDs. Now, in order to understand the object tracking algorithm, let's first understand what's the intuition behind object tracking. And to see the samples, we will follow only one specific object. Now we will get this, what is the red rectangle, ID2. Now, let's see the vehicle moving to another direction. Let's make him move a bit to another direction. Anyway, you see that it's working well, it's keeping ID2. And now let's again draw a bounding box right here, and we saw that the vehicle moved from area A, so from this one to another area. How does the StrongSORT work? StrongSORT incorporates the Kalman filter, which is able to detect and predict the trajectory of where the next position of the object will be. So understanding already the movement, the flow of the object, it can predict the trajectory, and then it will check if the object is in that predicted position. If so, it will move the tracking to that estimated position of the object. You see, for such simple scenarios like the ID2 right here, it works very well. Why? Because the trajectory is very simple to predict. we have a very smooth, predictable movement of the vehicle, and the vehicle is always visible in time. If, like it happens on different camera angles or more complex scenarios like people detection and tracking, there was some occlusion, or if we lost for any reason the detection of the vehicle, then we would lose the tracking. So this algorithm works decent in such scenarios, but they don't do any magic. They have a lot of room for improvement, and that's why it's something that it's always under research and that it's always improving and giving new updates constantly, because object tracking is something necessary but at the same time quite complex. Let's now see some other videos and let's compare the different algorithms, some of the different algorithms, to see how they perform. And for this one I want to go on the people detection because it's the easiest to understand, the most challenging one when it comes to keeping the same ID over time, despite the detection, problem with the detection, despite occlusion, and so on. So let's load people.mp4. Before we move further and we test everything, let me also tell you where you can get these sources. So everything that I'm showing you today, it's inside the AI Vision Academy. That's an academy where we have courses plus community. The courses that we're using today is the Detect Object Detection course. And it is a step-by-step object detection course where you can detect, track, and count any object, and you have access to very easy to follow lesson. There is a blog post for each lesson where you can get the details, and also each lesson has a very easy to download source code that you find right here. In addition to this, we have access to a community of developers, students, where you can also introduce yourself, ask questions about your project, so you can get project support. Here many are asking support for their projects. Then you can also interact with other people, and then you have access to Q&A group call. We have one monthly group coaching call where you can ask and get answer your questions. I will be in the community also to support you. And now let's test the tracker on this video with the people. So let's run this. This generally, you see we have the ID over each object, in this case over each person. We have the bounding box. Now I'm going to show you a general overview, then we will focus on just some of them so that we can understand what's happening and how to detect and track them. In general, you were seeing that many of them were detected correctly. Now let's put 0 so that we can focus better on each of them. And let's now focus on these ones right here. So where I have this square, let's now pay attention to what's happening in this area. So I'm moving frame by frame. We have ID 5, ID 12, ID 16, and 26. When we go further, we see that we have an extra ID. So when there is some occlusion or the people are not well visible, we lose the ID. So now we lose the detection of the person, that it might appear again later. We have 31, 26. So you see that there is some problem when the objects are not well visible. For example, ID 5, if 5 there is no occlusion, it's visible all the time, and we can follow and track that without any problem. As for all the other in the view, they are keeping the ID. But what you see right here is the ID, it's not kept. So we're at 43 now, 31. When we go a bit further, let's see the new IDs that get associated. $568. 31. Somehow it's able to keep some ID. Why? Because even when the object is not detected, it can wait for a few frames, and then if it's detected again in that position, then it gives again the same ID. This is StrongSORT algorithm that you can tune. So there are different parameters that you can tune on StrongSORT. For example, the minimum hits that you need to have before getting the tracker, the maximum age. So how long do you want to track that object after we lose detection, and so on. And now I'm testing this again. We got now ID in the 20. So you see when we move, we lose the ID. Now 420. There is a big mix right here. And it's happening on a very short time. So you can imagine if you have a camera running 24 hours, if on such a scenario, like it will be a huge mess with the detection. So it's very important to have a good camera position, to have like the best accuracy, but also choosing the right tracking algorithm. Now let's try different algorithms. Right here we have some other that we can try. We have byte track. So StrongSORT is like very basic. It just predicts the next positions where the object could be, and based on that it will make the association. We have byte track, which is slightly more advanced because it also, when we lose the detection of the person, I mean, like we lose it because we have a very low confidence, so the score goes below 25%, what we're showing. But byte track will take into consideration also the low scores when we put the low scores, and based on that we'll keep track of the object. So let's now try byte track on this scenario right here. We see now ID 5 is always ID 5, then we have 12, 15, while at the same time we have many other. You see that it's less sensitive, of course that depends also on the tuning of the different parameters. Now it takes longer to activate the tracking in comparison with StrongSORT. As you see, many of them are not even tracked yet, but that's mostly about the tuning of the model. And right here now it's not performing great so far on this square right here. It has much harder time to get the idea, but at the same time we will have much less false positive. With StrongSORT we saw that after a while we had like 920 ID. Here it takes much longer to give the association, but of course it's not working well. We will try now StrongSORT. StrongSORT is much more advanced because it will make also deep learning association. So not only will check the possible object, but also it will cut part of the image. So it will cut the bounding box and it will make association of that bounding box. StrongSORT integrates deep learning. We see it's working pretty well in comparison with the other ones, and we will see that over time it will be much more reliable to keep the ID. Why? Because it doesn't only check the location, but it also check if it's similar. So it will crop the rectangle with the person, and then it will compare with the new possible position if that's the same person, and that's why it's so much more reliable. You might be wondering, okay, if this is so good, why don't we use just this one StrongSORT all the time? Because there are problems, of course, with speed versus accuracy. Now I will show you running this in real time how with the graphic card I have it performs in comparison with the other ones. So if we run just StrongSORT right now, so now I'm running StrongSORT, and that's the maximum that we are getting in this exact moment with speed. There might be some optimization, of course, that we can do like for everything, but in general it's computationally very expensive, and we have our time to get in real-time speed, especially if we are running this on many cameras. Or of course you can get real-time speed that will be much more computationally expensive. So if you are renting graphic cards, if you are using Amazon AWS and so on, you will pay much more for this detection. So you need to find the balance ratio between speed versus accuracy, while if we run the same one either with StrongSORT or byte track, they have a very similar computational usage, then it's much faster because there is no processing. So now you see the speed, the FPS that we're getting with this is definitely much more than the other one. And let's now also do some tests on the other video sample that I showed you, so that we can get an understanding of this algorithm. For example, this one, now just for simplicity and for having better visual, I put the ID in the center of the rectangle because otherwise they will mix. And we see that the ID 8 and ID 20, 23, we have some occlusion. I'm using StrongSORT. With the occlusion even here, it's quite complex, and of course, these are very hard scenarios when especially you need to identify people. Either you work with the good camera positioning, or you need something more advanced solution that will require facial recognition and so on. Let's now test some other sample. There is another camera view, and of course this again, as before, can give an approximate estimation. You will never get from such angles like the very high accuracy, but you can get at least some good approximation of the tracking. And of course, this algorithm will work very well on vehicle tracking. Now, if we check vehicle tracking in general, the ID is very consistent, especially there is much less occlusion and the bounding boxes are much bigger. So when you test this with vehicle tracking, you will have a very high accuracy. Now, before we end this video, let me tell you what are the most common mistakes and pitfalls that you should avoid when doing object tracking, starting from the poor detection quality. So you use a poor detection model, and of course it's hard to have a good tracking quality if, first of all, you're not able to make the detection of the objects correctly. Before implementing any object tracking algorithm, make sure that you have the most possible accuracy with your model. So either improve the detection by improving the dataset, or if there are newer models, implement the newer models so that you can get the best accuracy possible. Not tuning the algorithms. So the algorithm that I show you, they all have different parameters, and when you use the default ones, consider each scenario is different. You have also different frames per second, so also that's very important. If you have a camera that works with 30 frames per second and a camera that works with 10, that means that the way the tracking reacts, it's much different, because if you have a lot of frames, we have a very smooth movement. If you don't have many frames, then this movement is very laggy, and the algorithm needs to take that into account. So not using the algorithm. And then one of the worst mistakes that you can do is to use the pre-trained models. Pre-trained model like the one that I show you, that can detect 80 different objects on Coco dataset. They are made for research purposes to show you how object detection works, but will not perform well on your scenario. So if you have a poor detection using these models, you will have a terrible tracking. That's guaranteed. And this is all for this video. I hope that you enjoy everything that we have seen so far. If you like this video and if you want to see similar in the future, I recommend to subscribe to the channel. If you want to access all the sources, if you want to access to me and to have my feedback on your project and a feedback of the community, everything is inside the AI Vision Academy, link down below in the description. This is all for this video. See you in the next one.